What if I told you that somewhere in the universe there is a place so cold that atoms nearly stop moving? A place colder than the darkest regions of space, colder than Pluto, colder than almost anything nature has ever created. A place where the familiar laws of everyday life begin to break down, and the bizarre world of quantum physics takes over. Most people think the coldest place in the universe must be some distant planet hidden in the darkness of space. Others might guess it's near a black hole or in the frozen outskirts of a faraway galaxy. But the truth is far more surprising. The coldest known natural place in the universe is something very different, and the coldest place ever created wasn't made by nature at all. It was created by humans. Today we're going on a journey to the coldest corners of existence. We'll explore frozen worlds, dying stars, mysterious nebulae, and laboratory experiments that push the limits of physics itself. By the end of this video, you'll know where the coldest place in the universe is, how cold it gets, and why scientists are obsessed with reaching temperatures that are only fractions of a degree above absolute zero. To understand the coldest place in the universe, we first need to understand what cold actually is. Most of us think of cold as something that exists on its own. We feel cold air in winter and assume cold is a physical thing. But scientifically speaking, cold isn't really a thing at all. Heat is energy. Cold is simply the absence of that energy. Everything around us is made of atoms. These atoms are constantly moving. They vibrate, spin, and collide with each other. The faster they move, the hotter an object becomes. The slower they move, the colder it becomes. Imagine a crowded dance floor. When the music is loud and energetic, everyone is jumping and moving rapidly. That's similar to what happens inside a hot object. The atoms are full of energy and motion. Now imagine the music gradually slowing down. People begin moving less and less. Eventually they barely move at all. That's what happens as temperatures drop. Scientists measure temperature using several scales, but one of the most important is the Kelvin scale. Unlike Celsius and Fahrenheit, Kelvin begins at the coldest possible temperature. This temperature is known as absolute zero. Absolute zero is 0 Kelvin, which equals negative 273.15 degrees Celsius or negative 459.67 degrees Fahrenheit. At absolute zero, atoms reach the minimum amount of motion allowed by the laws of physics. Nothing can be colder than absolute zero, at least according to everything we currently know about the universe. That raises a fascinating question. If absolute zero is the coldest possible temperature, how close has nature managed to get to it? Many people assume the answer is outer space itself. After all, space is dark, empty, and incredibly vast. It seems like the perfect environment for extreme cold. But surprisingly, space is not as cold as you might think. The average temperature of the universe is about 2.7 Kelvin. That's roughly negative 270 degrees Celsius. Now that's still unimaginably cold, but it's not absolute zero. In fact, it's almost 3 degrees warmer. The reason comes from an event that happened nearly 13.8 billion years ago, the Big Bang. When the universe was born, everything was incredibly hot and dense. As the universe expanded, it cooled. However, some of that ancient heat still remains today. Every part of the universe is filled with a faint glow known as the cosmic microwave background radiation. This radiation is basically leftover heat from the birth of the universe. It's incredibly weak, but it's everywhere. No matter where you go in space, you're surrounded by this ancient energy. Because of this cosmic background radiation, even the emptiest regions of space maintain a temperature of around 2.7 Kelvin. This means that simply drifting through deep space won't make something the coldest object in existence. To find temperatures even lower than that, we need to look elsewhere. Let's start with a place that many people think of as one of the coldest worlds in our solar system, Pluto. Located billions of kilometers from the Sun, Pluto receives very little sunlight. If you stood on Pluto's surface, the Sun would appear more like an extremely bright star than the giant blazing disk we see from Earth. Temperatures on Pluto average around 44 Kelvin, or negative 229 degrees Celsius. That's cold enough for nitrogen to freeze solid. Entire mountains and plains on Pluto are covered in exotic forms of ice. Some regions contain frozen methane and frozen carbon monoxide. For comparison, Antarctica, the coldest place on Earth, has recorded temperatures around negative 89 degrees Celsius. Pluto is far colder than that. Yet despite its frozen landscape, Pluto isn't even close to being the coldest place in the universe. Not even remotely close. To find something colder, we have to leave our solar system entirely and travel about 5,000 light-years away. There we find one of the most fascinating objects ever discovered, the Boomerang Nebula. The Boomerang Nebula is often called the coldest natural place in the universe, and for good reason. Scientists have measured temperatures inside this nebula as low as 1 Kelvin. That's just 1 degree above absolute zero. Think about that for a moment. The average temperature of space is 2.7 Kelvin. The Boomerang Nebula is actually colder than the surrounding universe. At first, this sounds impossible. How can something be colder than space itself? The answer lies in the way the nebula formed. At the center of the Boomerang Nebula is a dying star. As the star reaches the end of its life, it ejects enormous amounts of gas into space. This gas expands outward at tremendous speeds. When gas expands rapidly, it cools dramatically. You've probably experienced a tiny version of this effect yourself. If you've ever used a can of compressed air, you may have noticed that the can becomes cold while spraying. The same principle is happening in the Boomerang Nebula, but on an unimaginably larger scale. The expanding gas cools so efficiently that it drops below the temperature of the cosmic microwave background radiation. As a result, the Boomerang Nebula became the coldest naturally occurring location ever discovered. For decades, scientists considered it one of the most extraordinary objects in the cosmos. Yet even this frozen nebula is not the coldest place we've ever known. Because humans have managed to go even colder. Much colder. For centuries, scientists have been fascinated by the idea of reaching absolute zero. As technology improved, researchers began developing methods to remove more and more heat from matter. Eventually, they entered a realm where temperatures were measured not in degrees, but in millions and billions of degrees. One of the key breakthroughs came from an unexpected source. Most people associate lasers with heat, cutting metal, or burning objects. But physicists discovered that specially tuned lasers can actually cool atoms. Here's how it works. Atoms moving toward a laser absorb photons from the light. Each absorbed photon gives the atom a tiny push in the opposite direction. The result is similar to applying brakes to a moving car. The atoms slow down. And since temperature is directly related to motion, slowing the atoms lowers the temperature. Using laser cooling techniques combined with magnetic fields and vacuum chambers, scientists can reduce atomic motion to incredible levels. Temperatures fall to millionths of a degree above absolute zero, then billionths, then even lower. As temperatures approach absolute zero, something remarkable happens. Matter begins behaving in ways that seem almost impossible. One of the strangest examples is something called a Bose-Einstein condensate. This state of matter was predicted in the 1920s by Indian physicist Satyendra Nath Bose and theoretical physicist Albert Einstein. Normally, atoms behave like individual particles. Each atom has its own position, motion, and behavior. But when atoms become extremely cold, they begin losing their individual identities. Instead of acting like separate particles, they start behaving as a single quantum object. Imagine billions of atoms all moving together as if they were one giant atom. That's essentially what happens inside a Bose-Einstein condensate. Scientists have observed bizarre effects in these ultra-cold systems. Some materials can flow without friction. Others can climb walls. Quantum behavior that is usually hidden at tiny scales suddenly becomes visible. It's as if the universe reveals an entirely different set of rules when temperatures get close enough to absolute zero. And these strange states of matter aren't just scientific curiosities. They may play a major role in future technologies. Quantum computers, ultra-precise clocks, advanced sensors, and revolutionary communication systems all rely on understanding the strange physics that emerges at ultra-cold temperatures. But scientists didn't stop there. They kept pushing closer and closer to absolute zero. And eventually they created some of the coldest temperatures ever achieved anywhere. One of the most remarkable examples is NASA's Cold Atom Laboratory aboard the International Space Station. Launched in 2018, this laboratory was designed specifically to study matter at temperatures extremely close to absolute zero. The microgravity environment of space gives scientists unique opportunities to perform experiments that would be difficult or impossible on Earth. Inside the Cold Atom Laboratory, researchers cool clouds of atoms to temperatures around 1/10 billionth of a degree above absolute zero. That number is so small, it's almost impossible to imagine. To put it another way, these laboratory temperatures are dramatically colder than the Boomerang Nebula. They're colder than any naturally known location in the universe. Think about how extraordinary that is. The universe contains hundreds of billions of galaxies. Each galaxy contains billions or even trillions of stars. There are black holes, neutron stars, giant molecular clouds, and exotic cosmic phenomena beyond imagination. Yet one of the coldest known places ever created exists inside a laboratory built by a species living on a small rocky planet orbiting an ordinary star. That achievement represents one of humanity's greatest scientific accomplishments. But despite all this progress, there's one goal that remains forever out of reach: absolute zero itself. According to the laws of thermodynamics, reaching exactly 0 Kelvin appears impossible. Scientists can get closer and closer. They can remove more energy. They can slow atoms further. They can approach the limit with astonishing precision, but they can never quite get there. It's similar to walking toward the horizon. No matter how far you travel, the horizon remains just beyond your reach. Quantum mechanics adds another twist. Even at the lowest possible temperatures, particles still possess something called zero-point energy. This means there is always a tiny amount of motion that cannot be removed. Nature itself seems to prevent complete stillness. The universe refuses to let matter become perfectly motionless. Absolute zero remains one of physics' ultimate boundaries, a destination we can approach forever, but perhaps never reach. And that's what makes the search so fascinating. The quest for the coldest place in the universe isn't really about cold, it's about understanding reality itself. Every time scientists push temperatures lower, they uncover new mysteries. They reveal hidden behaviors of matter. They test the limits of physics. They explore regions of nature that few people ever think about. When we imagine the extremes of the universe, we often focus on the hottest stars, the largest galaxies, or the most powerful explosions. But the coldest places are just as extraordinary. From the frozen plains of Pluto to the breathtaking Boomerang Nebula, nature has shown us temperatures that challenge our imagination. Yet humanity has gone even further. Using lasers, magnetic fields, advanced engineering, and decades of scientific innovation, researchers have created environments colder than anything naturally known in the cosmos. In those ultra-cold laboratories, atoms behave like waves. Matter enters entirely new states. The quantum world emerges from hiding. And somewhere in those experiments may lie the key to future technologies that could transform civilization. The coldest place in the universe is more than just a location. It's a frontier. A frontier where science meets mystery. A frontier where the familiar world disappears and something stranger takes its place. And perhaps most amazing of all, it's a frontier that humanity continues to explore. If you enjoyed this journey to the coldest places in existence, make sure to subscribe for more explorations of the universe, science, and the mysteries of reality. And here's a question for you. If you could instantly travel anywhere in the universe for 1 minute, where would you go? Let us know in the comments. Thanks for watching, and we'll see you in the next video.